Hi, my name's Silas. Welcome to my home. This is a small one-bedroom condo in a 4-unit complex that I've lived in for about 5 years. I've been kind of obsessed with climate change for a long time, but now suddenly I have a property that I'm responsible for. So I liked the apartment a lot when I bought it, but I recognized that it's an older building. It was built in 1952, and it had an old gas furnace and a gas water heater and a gas stove, and I knew at some point I wanted to change those things out. Because I wasn't sure what I wanted to change, I hired a company that does energy retrofits to do an energy assessment of the building. When I got the energy audit, which I recommend you do if you want to do an energy retrofit of your home, I really learned a lot about what to do next, and it wasn't just about electrification. So the first step was to air seal the building envelope as much as I could. And that means finding as many of the holes and penetrations in the ceilings, walls, floors, and even the interior walls as you can, and sealing them up. So one of the first things I started with are these recessed lighting cans, and warm air rises, so you're going to lose heat from your living space to your attic. So I replaced all of the existing cans with what are called airtight insulation contact recessed lighting cans, which are designed to seal to the ceiling and allow insulation above them. After I tried to seal everything, I insulated the floor with mineral wool, which looks like fiberglass, but it's more dense and fits more tightly for between the joists of the floor. All the exterior walls were insulated by drilling holes and blowing in loose fill set. So this is my attic. It actually looks pretty similar to when I first got the place, but I've done some significant changes. So it had a plywood deck, which allowed it to be a storage space, and I didn't want to give that up, but I wanted to improve the insulation. So I took all the plywood out, and I built a new frame about 9.5 inches up from the original joists so that I could blow in insulation, and then put the plywood back down. It's now about 9.5 inches higher than it used to be. Still enough space to have plenty of storage. To seal the trapdoor, I ended up building a second trapdoor on the top of the one that you saw that's made out of insulation foam and plywood, and it just drops down over the trapdoor to seal it and insulate it so it doesn't leak hot air up into the attic. So once you seal a building to a certain extent, you no longer have as much natural ventilation, so you have to at least consider the possibility of installing mechanical ventilation. Indoor air quality is important to me, and I wanted to improve that. And I also wanted to do it in a way that is energy efficient. Two of the things that were important to me about this was that it not take up a lot of space and that it be quiet, because this is such a small apartment. I don't have a lot of storage space, and I really like quiet when I sleep. So I ended up deciding to put it in this closet. Was the best space. It's conveniently located between the kitchen and the bathroom. And this box that you can see down at the bottom amongst all my stuff is a heat recovery ventilator. It's basically an air-to-air heat exchanger that brings in fresh air from the outside and at the same time pulls exhaust air from the living space, and it passes them through an air-to-air heat exchanger. What that does is preheat the incoming fresh air with outgoing air that's been warmed in the space. So you end up not bringing in cold air, but bringing in pre-warmed air without losing a lot of heat that you've spent so much time or money or electricity to generate. What that does, in addition to providing fresh air, creates a circulation through the apartment. So the fresh air is coming in through the kitchen, through the bedroom, and out the bathroom. So this is the little bathroom. A couple of things to show you here. Up here is the intake, or rather the exhaust vent for the ventilator, which also doubles as the shower vent. So when you take a shower, you hit the boost button, that turns on high. It's very silent, you can't even hear it, but it pulls out more air than the original bathroom vent, so it works really well. The other thing I want to show you is how I reduce my water use in the shower, which is probably one of the biggest water uses in the house. I put a shut-off valve, which you can buy easily, between the pipe and the shower head. That allows me to adjust the flow, and that can turn any shower head that you like into a low-flow shower head. You can just adjust that valve to a lower flow rate and still have a pretty comfortable shower. And I put a little flow meter on here that tells me how many gallons I've used in each shower. With such a small space, I wanted to get a heat pump that was sized appropriately for the space and that minimized the use of high global warming potential refrigerants. After a lot of consideration of what's available, I ended up choosing what's called a packaged terminal heat pump. The entire unit including the compressor and all the coils, are in one box inside the building, and it's connected to the outside through two 8-inch ducts that go straight through the wall. This particular unit comes with a remote control, so I can power it on, set the temperature, and operate the louver. And this particular unit also comes with a Wi-Fi app, so I can control it from my phone remotely or in the apartment. So one of the things that improving your building envelope allows you to do, in addition to making your home more efficient, is you can shift the time that you use the electricity that you've now shifted all of your heating and cooling loads to run it during the middle of the day when solar electricity is abundant. This apartment is now insulated enough that I can run the heat pump almost entirely between 9 a.m. and 3 p.m. and then turn it off, and the apartment will stay warm enough overnight until the next morning. The last step in electrification is to swap out a gas stove that was in this kitchen. Replaced it with the same brand Frigidaire induction cooktop, which allowed me to do a couple things. One is it's just really nice to use, and I think anybody who prefers gas over induction probably hasn't tried induction yet. The other thing that was nice about it is it's only about 2 inches deep, and it allowed me to put an extra drawer for silverware. I noticed pretty quickly that the glass surface was getting scratched from pots, so I found a product that I found pretty useful. It's just silicone and fiberglass mat that goes on top of each burner. It's thin enough that it doesn't affect the operation of the stove, and induction ranges are nice because the cooktop never gets hot enough to burn or melt anything. Above me is one of the first little projects I did, which doesn't actually probably save too much energy relative to LED bulbs, but that's a set of Solitube daylight tubes, and it brings in sunlight from a lens dome on the roof and brings it into the kitchen and the living room, as well as the bathroom. Everything else that I've shown you was just in my apartment. This is a 4-unit building, and we have a small HOA, so after I had finished electrifying and insulating my apartment, I wanted to replace the water heater that we share. That required me to get buy-in and permission from 3 other owners, but I did. I persuaded them to put in a pretty expensive system, and part of the way I did that was by the rebates that are available for heat pump water heaters. About 2/3 of this project for the water heater was paid for by rebates through BayREN and TECH Clean California, and hopefully the other third of it will almost entirely be covered by new tax credits from the Inflation Reduction Act. So this will almost, if everything works out, be a free upgrade. This one has the compressor outdoors, separate from the tank, and it's connected to the tank through these 2 pipes that travel through the crawl space and over to the tank, which holds about 120 gallons of hot water. This system's somewhat unique in the United States that it uses CO2 itself as a refrigerant. So if there's any refrigerant leakage, it's a tiny quantity of CO2 and has 0 impact on climate. I wanted to find a way to load shift the hot water heater as well, to bring the bulk of its power draw into the middle of the day when solar electricity is available. The water heater we chose doesn't have built-in capacity to do that, so I found that I was able to add on an additional thermostat and relay switch, and now I can control the times when the heat pump is running to move most of it into the middle of the day, and because the capacity of the water tank is large enough, so far none of my neighbors have complained that we've run out of hot water. In order to electrify my apartment, I did have to upgrade my panel. The remainder of the panels are older and have old fuse disconnects. If anyone else in our building wanted to electrify, they would have to upgrade these meters because the main service is not sufficient to electrify the entire building. So I was able to get my neighbors to allow me to install an EV charger. There's probably space for a few more, but I'm the only one here so far with an EV. And I will show you in a minute, I also installed an inlet port to, in a power outage, be able to draw some power off the car to run refrigerator, lights, and a few other things. This is an aftermarket 1500 watt inverter connected to the 12 volt system in the car and connected by an extension cord to a single circuit that I installed from the wall of the building into my apartment. It's not connected to the grid, it's only for emergency power input, and it allows me to power a refrigerator and a few other essentials during a long power outage. That's about it. Thanks for visiting my little house, and this has been a really fun project for me. I found it really satisfying over the last few years, partly because I like to do projects like this myself, but also just learning about the technologies and the changes that are possible to transform older buildings that are designed in very inefficient ways into much more efficient, much less climate impacting homes that we can all live in.